Hello guys, and first of all, welcome to my channel. The purpose of making today's video is I see a lot of undergrads, you know, write certain algorithms, but they try to understand how we can write them in a more scalable fashion. And one of the things that I see is like there's a disconnect between some of the things that they have learned, like operating systems and computer networks and database management systems, but they have not used the core concepts that they have learned in terms of actually coding something. So I thought that this might be a great opportunity for them to basically learn something. So right now what I have is something called Project X. Project X is like one of my personal projects that I have been working on. It's basically a vector database, but its memory footprint is very low. It's designed for speed. It's written in C++, so completely, native kind of algorithms are there. It works. It's a vector database. Now today, you might have worked with in your college days. You might have worked with your traditional database, like you have the either an SQL database or a NoSQL database. Um, a vector database is also a database. It's pretty similar, but not same. So in SQL, what happens when you have this relational databases? So when you search, you basically write a query, and the query is essentially a sort of a match of strings that you're trying to do. Now, this is for a vector database. This is different in the sense that we try to find out a sentence that is very close in context to some other sentence, and the way we do that is basically to use we basically project these embeddings. Like you have sentence, we convert it into you for words, we basically convert it into embeddings. Embeddings is just a vector, or you can think of it as a list of numbers. So these vectors are then projected into a space, and the distance between them is then found out through various techniques. We have a lot of them in our you know uh, database. For example, you have the similarity engines, you have the Chebyshev, you have cosine, dot, Euclidean, Hamming, Jaccard, etc., etc. So these are some of the metrics on which the table works. Now, how this database is, so the version 1 of this database is already released. The version 1 of the database primarily has it's more like in memory. So you have something like a key space. A key space is then you have a block that is been stored inside the key space. So you can think of key space as a table wherein you store the data, and then you have the block. You can think of the block as like memory block in which records get stored, and then you have and for each key space, the difference is like in SQL or in NoSQL, we have matching some matching query or some matching strings that are there. But this is a vector database, so what we have is like a metric. So each key space or a table is basically assigned a metric, and this metric is then within that key space there are certain blocks of records that are there, and whenever a user provides the input for a given metric, then you know the block basically it kind of searches the block and finds out the data. Let me give you an example, that way you will be able to understand better. This only works in Linux. So if you are like in a Windows system, you need to have WSL, Windows Subsystem for Linux. Now if I just write project X, oh sorry, project clear project X. So now it says welcome to project X vector DB CLI. So this provides you with the CLI access. Now we have the first thing that you might want to do is create a key space. Create a key space, let's say demo. So this creates, now I you can actually provide you know um, the metric that you want to use. For example, if you do not provide any metric, it will take default cosine, but um, if you provide with metric, and you can provide some metric whatever you want based on your needs. Now this is all fine. Now insert, let me insert one record, insert into key space demo or the okay, insert demo. Let me just give one, you know just a random sorry, a list key space, list key space unknown list option. Oh, okay, yeah, sorry. So I was just trying to list all the key spaces that are there. Now if you show so now if you want to, for example, one of the things that you'd want to do is to see what the data you have, what are the records that you have. So you can actually take let's say show records in the key space, which is at the moment. So you see you have only one record. Now you can actually uh, you know take the metric for that, metric for the key space key memo. Oh, sorry, show metric for is using metric cosine. Okay, so this is how it works. This is a very simple example. You can do a lot of things. I will share the GitHub pages repo for this, and you will be able to understand what it's able to handle. So as I said, that the version 1 of this app is already released. Okay, now it had, the version 1 had some, um, what do you call it, some shortcomings. The shortcomings were like, one of the things was disk persistence. The data, so this was project X, was the version 1 was a kind of an experimental version, which was primarily used for research and development. Now for this kind of changes, you have we only have the entire data set in memory. So for example, if a developer wants to do some R&D with some of the vectors that he has created, he can actually offload it into some CSV file or any other file, and then he can ingest that into our database. It will be basically ingested into a key space that he will create. Okay, and then all the records will get ingested, and then he can basically change or alter the metric on the key space, and then query the key space for different whatever he is trying to do. So this was like a very experimental version, Now we are moving towards something which is much more concrete in nature. You have now one thing that I would like to implement for the version 2 would be disk persistence. As I said that currently the entire data gets ingested into the key space, but it remains on the RAM. It doesn't go on the ROM, right? So, for example, if something happens, or um, if the developer wants to start a new session, he will have to create a new session and ingest the data again. So the entire thing has to be done again because the data exists on RAM. It doesn't exist on the disk. So that is one thing that we would like to do. Secondly is indexing. Currently the search is pretty much linear in nature, which might not be the best suited for our database. So we would like to implement some indexing. We would like to implement transaction handling. You might have already heard about the asset properties for database. Something similar we need to do for our vector database as well. Fourthly, we have multi-threading. We want to implement some batch operations. Currently it's single threaded application, so the batch operations might make it more, we can actually process queries in batches, and we can actually manage multiple connections at the same time, uh, which is also one of the things that we want to work. So these are some of the things that we want to work, and I am starting my work on disk persistence at the moment. uh, so I'll be like starting to code, and you can actually observe what are the things that I'm doing. In that way you will you know get an understanding of how you should be writing the code, and what you should be doing, in the how to design. You will see that many of the concepts that you have learned as your under as part of your undergrad will actually be used here. So yeah, let's start. So when it comes to disk persistence, one of the things that where I have to change is, you will see that is this header file called commonutils.h. Now commonutils.h has two interfaces. One is the save db, and the other one is load db. The save db basically saves the data onto the database, and the load db basically loads the data. But at the moment, as I said, that one of the shortcomings of this is that the entire data exists on the RAM. It doesn't exist on the disk. So we would like to make that change. uh, so the first thing that I would do probably is to change the interface here. So we can have save db. We will take the constant key space, and the name. um, so this is like an overloaded method for save db, that will take the key space along with the key space name. We will need it when we want to persist the data. Now that is for one change. Now the other change would be in the core implementation. Now when we come to the commonutils.cpp, here you will see that there is already something called save db. Now we want to expand the functionality for this. This was like written way back, and the functionality is very simple in nature. The functionality only deals with some JSON data, and we are kind of opening the file, reading it from there. But this is very inefficient in nature. Um, for example, uh, okay, sorry for the interruption. Um, Now, okay, where I was, yeah, I was in the save db. Now what I'm going to do is I'm going to create an anonymous namespace here. um, okay. So so there are a few things that we need to consider before we even start coding. One of the things is like what should be the data format for the file that we are using. Now, as you remember, the one of the main motives for or one of the main guiding principles when we were developing Project X was to have a very low memory footprint. Uh, so keeping that in mind, we have certain good alternatives. For example, JSON, but JSON is not very optimized in terms of the usage for the things that we are trying to do. A better would be, or a most optimized thing that we can perhaps use is basically a binary file. A binary file will just have the data in a certain format, okay, and we can read that reading the binary file and getting data from it would be much more optimized compared to what JSON does, because JSON will have JSON will use a lot more memory footprint. Now, there is also a downside to using binary, which is like uh, for JSON you can actually cat through the file and basically see if there's anything that needs a change. But when it comes to you know but when it comes to this um, binary, it's not very simple, because the data will be stored in the form of bytes. So that kind of human readability will be not there for a binary file. But given that it provides us a more optimized solution, it's basically what we are going to go forward with. Now, the first thing that we might want to do is to declare a magic encoding. So we have constant expr, a constant expr char magic for p x v p. And the other thing that I would like to do is const expr. Did I write something wrong? Um, per, yeah, constant unassigned integer 32 and format version equals to 1. Okay. Yeah. So these two are basically, you might be wondering what these two are. So this is like an encoding that will tell our reader that this is the correct data file that you're looking for the database. These kind of encodings exist for many other formats. For example, for PNG format, there is a encoding that is there that is used to check if a certain file is really a PNG file or not. So these kind of encodings are there. So we can choose this particular encoding and we can choose this format version. Now we have to basically write two functions. One would be the write the key space file, and the other one would be like to read from the key space file, right? So let's start with the write key space file. What we would need for this is three things. One would be the key space name, the second would be the metric, and the third would be the records that are there within the file. Okay, so we can start with declaring the function like void write key space file. We have constraint the name, right? Then yeah, the name. Then you would require the uh, name and the metric name. So metric, and you would then require the records. So the records are like you know sorry, I, this would be string, and the records would be like vectors, and within that we have another vector, and we have float, and this will be in records. Okay, yeah, that works. Sorry, this will be, yeah. Okay, now the first thing that we would want to do when we are trying to write uh, the data onto the key space is to basically create the file, and before creating the file we would want to create the directory in which the file needs to exist. So we can have like a file system, then create a directory. Let's call our directory the data directory. So we have created a directory. Now there are like two things. The idea is like whenever someone writes something to the key space, the data is going to persist. Now what we are going to do is but we have to also like take care of the failover scenario, like if the database crashes or the instance crashes, do we lose the data that we have written to the key space, or what happens? So in order for that to not happen, what we are going to do is like we are going to create a temporary file, okay, a sort of a temporary file in which we will write the data, and then we will rename that temporary file into the bin file once all the writing is done. Okay, so that way we ensure that even if we were not able to write the final version because there was some sort of crash of the system, the temporary version still exists, and we can actually create the data, or we can just try again creating the data from the temporary version of the file. So let's say what is going to be the final path and the temporary path. So let's say string final path would be the data directory that we have created plus the key space name plus .bin, because we are going to create a binary file, and the temporary path is just going to be the final path plus .tmp. Okay, just giving it some sort of temporary version, and as I said, at the final moment, once every writing is done, we are simply going to just rename the temp path to the file path to ensure once that renaming is done, we'll be sure that we have created whatever we want to create. Now moving forward, the first step that we would want to do is to basically open the file. Okay, and we should be able to write to the file. So let's do that first. um, Standard, let's io of stream sorry file off stream, and then you have, this is the function, the file. Now you write the file path, which for us will be the temp path. What is, yeah, temp path, because right now we are trying to write into the temporary file, not the actual file. Okay, and then IO stream binary, sorry, stream trunk. So basically what this line does is it will open the file given in the temp path. If the file is already there, it might have data from one of the previous writes, so it will truncate it. It will open it as a binary file, and it will, if the file is already there, it will truncate that file. Okay, now we have to check if the file is opened or not, so we can do that. If file dot is open, if the file is not open, we should simply log an error saying that unable to create temp file on the system, and we can give the key space name and some slash n. Okay, and we should also return from here because there's nothing more we can do. Now this is like the negative part. Now we are going to the happy part. Now when we happy part means the file is already open, right? Now thinking of from a read perspective, the file is to be read in a certain fashion. Like as I said, that there will be some encoding, the magic words that we have mentioned here. These magic words will define if the file that we are trying to work on is actually correct, and if that needs to be done. So the first thing, and therefore this needs to be kept in mind when we are also writing data onto the file, because if we do not follow the standards and if we just write the data records in some fashion into the file, during the read time, it will, if it doesn't get the magic words, it will not identify it as as the binary data file that we are trying to work with. It's very similar to like any other format. Like for example, in PNG you have a magic encoding there as well. So if the file, whenever some sort of PNG displayer opens the file, it will first check for that encoding. If it's not there, it will know that this is not a PNG file, or the PNG file has been corrupted in some fashion and cannot be opened, because it's not sure if the data can be processed. So the similar thing that we have to also take care of. So the first thing that we are going to write here is basically the magic words that we have, the encoding that we have. So sorry, magic and the size of magic. Right. So what I am telling the system here is like to write the magic encoding and size of magic, because write takes two parameters. The second parameter is the number of bytes that needs to be written or that needs to be read. So we have to also provide the size of. Similarly, the other thing that we would like to write on the file is basically the format version, because in future the format might also change, right? So the the database should not pick up data files which has a different format, so that shouldn't be the case. So that we should also write it in that fashion. Now here you see the format is basically unassigned integer of 32 bits. uh, we we can't directly write that, because the write function actually takes a char star kind of input as part of the first argument. So what we have to do is, like, we have to reinterpret the cast and kind of reinterpret it as const star, and then we can actually use the format version to write. So let's write that file dot write reinterpret cast const char star, and the format version, and we need to write, sorry, it's off, the format version, right. So we have written the magic keywords and format version. Now we also need to write some other things, like what is the length of the metric that is being used for that particular key space, and what is the you know uh, like the metric data. So yeah, so basically for example, it will be like the encoding that will ensure that the data file is correct. You will have the format version to ensure that the format version is the correct version, and then you have the metric that the key space is using. Okay, so but as you know, the file dot write, you have to provide the metric length as well. So we would probably first want to find out what is the metric length, and from there we can actually write it. Uh, we can actually write the metric length as well as the metric data. Okay. So for the metric length, let me take an unassigned 32 integer, and let's say we give it a name metric length, and we can have to do a static cast here, and this should be cast into into unassigned 32. So 32, and whatever is the you know uh, so it will be like metric dot size. So this is the metric length that we have got. So we can actually, now that we have the metric length, we can actually write the metric length onto the onto the file. The only thing is, like, the metric, as I said, that the write function takes char star, so we have to again reinterpret the cast and provide the number of bytes that the metric length basically occupies. So we can actually do that. We write file dot write. We can have the reinterpret cast const char star, and const char star. We can have the metric, sorry, metric length, and the other thing that we want is the size of length. Okay, cool. And finally we have to also write what metric it is. So we can take metric dot data, because anyway it's in and in char star, and then with that we can just take the whatever is the metric length that is there. So it will be okay, right. So this is all done. Now another thing that we might want to write on the file is the record count. Okay, how many records are there in that particular key space, because this might help us in the future. Now we already are getting the records, but record count can be larger, so we won't use unassigned 32. I would probably go with unassigned 64 here. So I'll basically create an unassigned um, 64 record count, and we can have the sorry, you can just close this is not required at the moment, the record count, and we can take a static cast for that, and we can take the unassigned 64, and we can take the whatever is the record size. Okay, so that would be our record count. Now all we have to do is just write the record count. So but again, record count is like unassigned 64, so we have to, you know, do a reinterpret cast on that as well. Sorry, this will be star and record count, okay. So now we have everything, at least we have written all the areas. We might want to leave some comments here for the developers to know. Here encoding and version is written on the main data file. Then you have the metric length. So this is like the metric type and length written on the data file, and finally you have the record count written onto data file. Now it comes down to writing the main records. Okay, so we will start a for loop for all the records in records. Right, so what we want to do, the first thing we would want to do is to basically write the record length, and if the record length is greater than 0, then we actually write the record data. Okay, so because we are actually now dealing with individual records, the record length is not expected to be very long, so I'll probably stick to 32. This was a static cast of this will be records rec.size. Yeah. Now the unsigned, this is like the record length, so file dot write reinterpret cast const character length and the size of sorry, size of is not required, we already have that. So sorry, size of is required because it's not in bytes, it's in integer unassigned 32. So get length. Now we are gonna check if this is if the record length is greater than 0, then we need to write the data onto the file. um, we have the record data, and we have the now we cannot directly give the size of, because the record itself is like an array. So what we have to do here is like give a size of float, because each number will be float, and that needs to be multiplied with the length of the record. So record length, that will be the total number of bytes that needs to be written. So that is done. Now once everything is completed, what we can do is just flush the file, because our work is done with the file, right? Now if the file is not good after flushing, then there is some sort of error. So we need to log that error. um, Sorry, CERR, something went wrong writing data to file name. Okay, and we return. And if the file was good, then as a last step, what we need to do is to rename that file from the temp to the file path that we actually want it to be, like in the binary. So what we are going to do is, first we will take the error code, because something can go wrong in that, let's say EC, and then we will take the file system, sorry, and rename the file, which is currently the temp path, to the actual file path that we want. What was the name of that? Forgot. Final path. Okay, final path. And the error code, if something goes wrong, it will pass that to the error code that will be there. Now if there is some error, it will give some error code. So we can write like CRR something went wrong with creating the final binary file. Okay, and we can also return from here. Yeah, so that is all for the write functionality. Now I'm getting late for one of my work, otherwise I could have also completed the read functionality, but in the next video I will also deal with uh, you know the read functionality, and then we will combine both of them to basically add the next level of details onto individual commands and see how it will materialize in the long run. Okay, so I hope the main intention with which I wanted to create this video was for especially the undergrads to understand how we write the code, how we before writing the code, planning is the most important. So if you are planning correctly, then things are going to work out. If you are not planning correctly, if you have not understood the requirements, if you are not clear on what needs to be done, then you might not be able to ask intelligent questions to yourself, and that might be one place that you might be losing out. For example, I could have gone with a JSON file instead of a binary file. Okay, but I know what the end goal is going to be. I know that the memory footprint has to be less. That's why I went with the binary format, although it has some downsides to it. So this is just one example. um, I like when we will go into the read mode, when I'll write the read key space function at that point of time, and then when I alter the commands at that point of time, we'll see how the data is being read, how this magic encoding that we have added helps, how this format version helps, and the rest of the things whatever we have written, we'll see how it kind of gets used in the long run. So this is just the first part of the development. In the next part, we will be doing the part 2 of this disk persistence, which is to read from it, and all the other changes I'll keep making videos, so you can actually follow how the development is done and what needs to and what's happens, etc, etc. Okay. uh, the changes for this is there will be there in feature data persistence branch. I'll leave the repo as well as the the official page for project text in the description. You can actually go there and use it. As I said, that the version 1 is already released, so you can actually download that version, install the libraries. You just need to call this install.sh, and this will automatically install all the dependencies that is required and basically run your application. So yeah, you can actually have a go through it to understand how this vector DB has been written, and we'll see you in the next video.